Hey guys, so we continue on our journey into the world of PIC microcontrollers. In our last video, we looked at setting up the device. In this video, we'll take things a bit further. We'll talk about why blinking an LED is so important. You see, in electronics, there's an entire section of electronics dedicated to one thing, a subsection of electronics known as timing circuits. Now, this section can probably be skipped by those of you with more advanced electronics knowledge, but it contains critical concepts that you should be familiar with. In electronics, we can combine resistor and capacitor circuits to create what are known as RC circuits. Now, these RC circuits form the basis for a lot of electronic timing circuits. You see, when we try to charge a capacitor through a resistor, the resistor limits the amount of charge that can be put into the circuit. If you put a bigger resistor, it will take more time to charge the capacitor. So by varying the size of the resistor and the capacitor in the circuit, the capacitor will charge or discharge in accordance with what we call the time constant of the RC circuit. This time constant is given by the equation T is equal to R times C. This time constant, T, is in seconds and is given by the resistance in ohms and the capacitance in farads. Or if you like, you can use the resistance in megohms and the capacitance in microfarads, which is more convenient for most practical applications. So according to how we combine the resistors and capacitors, we can get the foundation of a circuit class we know as multivibrator circuits. You see, the output of an RC circuit can be made into a 0 or 1 by combining it with a digital gate such as a Smith trigger or a NOT gate. We get what is known as a monostable multivibrator circuit. A monostable circuit is just a circuit that has one stable output, either a 0 or a 1. And when the circuit is triggered, it temporarily goes into the opposite unstable state before returning to the stable state of the circuit. We could also configure RC circuits so that they behave as astable multivibrator circuits. An astable multivibrator circuit is one that transitions from one state to the other constantly at a time interval. This forms the basis for a useful concept in electronics we call oscillation. Specifically, a non-linear relaxation oscillator, since thanks to the gate, the output of such a circuit will be a square wave. So there is also a bistable multivibrator that can be stable in two ways. If we use an external trigger, we get the output from the circuit that is stable in either state. This forms the basis of a flip-flop, which is fundamental in electronic circuits and memory circuits. Now, timing circuits are so popular that we have an integrated circuit, which in my opinion, along with the 741 op-amp, form the most popular integrated circuit PI in history. The integrated circuit I'm talking about is the 555 timer, which is one of the most versatile integrated circuits ever invented. You see, the 555 timer can function as either a monostable, bistable, or astable multivibrator. And once you have a clock to work with in electronics, you can get all types of interesting electronic circuits. So you're wondering, what does this have to do with PIC microcontrollers? Well, the thing is, PIC microcontrollers can programmatically be modified to function as either as a monostable, bistable, or an astable multivibrator. When we look at the blinking LED, we were already exposed to using the PIC microcontroller as an astable multivibrator, since the output of the microcontroller toggles from a high state to a low state. To use the bistable and monostable modes, we will connect a push button to the microcontroller. You see, microcontrollers are good not only at outputs but also at inputs. So let's connect the circuit on our PIC microcontroller, which is given in the schematic. We connect the push button to the PIC microcontroller shown in the schematic. This is called the pull-up configuration. There's also a pull-down configuration, but we'll stick to the pull-up configuration for now. For most circuit purposes, this does not really matter. There's also a method we can use to enable internal pull-ups with any microcontroller. I'll link that program in the description below, but usually we'll just use external pull-ups. Let's look at the output for a monostable configuration. In this program, we'll read our push button, turn on our circuit for a period of time, then the program will turn it off. We'll also look at the bistable operation, where when you press the push button, the LED output goes high until we push it again. Then it goes into a low state. And of course, our astable blinking state. In this state, our LED blinks constantly regardless of the input to the circuit. If we look at our program code, we see that in order to make the PIC microcontroller turn into an input, we must set the trish register of the microcontroller to a 1. We must also disable the analog input for that device as it will interfere with our circuit. Once we have this done, we can modify the delay within the PIC microcontroller and upload it to our chip so that we can get monostable, bistable, and astable operation. In the next video, we'll discuss inputs in more details.